All right, I'm going to walk through 4a from the reflection. And in this problem, we are given this polynomial, but we are also told what the factor was, and we were also told that they already divided and they were left with this quadratic. So really, they did that first division step for you. You just needed to know to finish it. And in order to finish this, we're going to use quadratic formula. So I've got an a of 1, a b of negative 11, and a c of 18. I want to remind you that a, b, and c are always numbers. They should not have any variables in them. They're always the coefficients of these. Okay, so I'm going to put this into the formula, and the formula is on the back of your bookmark that has the perfect squares on it, and we've also put the formula in multiple other notes. So I'm going to sub in the opposite of negative 11, plus and minus. I've got negative 11 squared minus 4 times 1 times 18. And all of this is over 2a. Nope, and our a is 1. So I can just sub that in. Okay, so on the next line, I'm going to simplify it. The opposite of negative 11 is a positive 11. And 2 times 1 on the bottom is 2. So here, I've got 11 squared minus 4 times 1 times 18. I'm just going to put this into my calculator. So I'm going to set that up. And actually, I'm going to use Desmos for that just because that's what I have open right here. So we're going to put in negative 11 squared minus 4 times 1 times 18. Okay, and that gives me 49. So the number under here is 49. So I'm looking at my perfect squares, and I notice that 49 is a perfect square. So I've got x equals 11 plus, and I'm going to do a minus version of this, over 2. And that 49, the square root of 49 is 7. So you can't stop here because these are numbers that you can actually put together. There's no I on them. There's no radical on them. So I've got to simplify these. I can do 11 plus 7 over 2 and 11 minus 7 over 2. So 11 plus 7 is 18, and that divided by 2 would give me 9. 11 minus 7 is 4, and 4 divided by 2 is 2. So all of my roots, we know we have this 9, and we have this 2, but there are actually 3, and I know there are 3 because I have a degree of 3. So in order to get that third root, you need to come up here to see what that initial factor was that they used, and that initial factor helps us find the last root. So your last root is negative 1. So you need to list all of those, 9, 2, and negative 1. For this problem. And the problem on the test itself asked you for all of the factors as well. So you could even just find this one first and see which answers had that in it, and then cross off the ones that didn't even work, and you were probably left with only 1 or 2 answers at that point. So that is 4a from the reflection on solving polynomials algebraically.